Alright, so in this video we're going to learn about significant figures. So when we talk about significant figures, really we're trying to look at a measurement and then decide, okay, how precise is this measurement? And also, when you report a result that you use measurements with, so you take your measurements and do a calculation, you need to round in a very specific way that shows the precision of your measurement. So that's why we use a lot of these rules that I'm going to show you, and that's also why you're not really going to see this in math class. Like when you answer a math question and you calculate your answer, let's say that you put a number or some numbers in a calculator, you calculate something back and get like 5.3 or 1, 3, 4, 5, 6, whatever, and it has a bunch of digits. Well, when you report that answer in chemistry, you're going to report it a very specific way. And rounding, when you're talking about in your math class, your teacher probably would say round to 2 decimal places. Well, that's because it's not based off of a measurement. If it's based off of a measurement, you have to indicate how precise your measurements were. Okay, so your answer, your calculation, should only be as precise as your least precise measurement. Now, if I'm reporting this kind of indicates a lot of precision. There's a lot of digits here. So really that would depend on your original measurements. Okay, so when you are looking at a number and you're trying to decide, okay, how many significant figures are here? Basically, how precise is your measurement? Also, which numbers matter when I start to round it? So you're going to count all the numbers or all the digits except for leading zeros. So leading zeros are going to be the zeros in the front. So this would be a leading zero, so would these two, even though it's after a decimal point. It's before anything else. So if you have a number that's less than 1, you have leading zeros. So technically this would still be a leading zero. It would not be significant for rounding purposes. If I have 0.00005, again, all of these are insignificant for rounding purposes. So the 1, 2, 3, 4, 5. You have 5 leading zeros here because this number is less than 1. All of these zeros are in the front. They are leading the line. Okay, you also do not count trailing zeros without a decimal point. So 2,500, these zeros at the end, they're at the back. Okay, there is no decimal point, so they're not significant for rounding purposes. So I only have 2 significant figures. Now, let's say that I have that same number, and then I add a decimal point. They do become significant because there's a decimal point. Again, if I add another 0 here, they're all trailing zeros. However, there's a decimal point. Okay, that decimal point indicates something to us. So I would have 5 significant figures here. If I add another 0, it would become 6. All trailing zeros with a decimal point do count. So again, the only numbers we do not consider significant to be are going to be the leading zeros, the numbers in the zeros in the front, and then the trailing zeros without a decimal point. Okay, so let's count. Okay, so this first number right here, 23.50. Okay, do I have any leading zeros? No, I don't have any zeros in the front. Do I have any trailing zeros? Yes, I do have 1 0 in the back. Okay, so that 1 0 in the back is going to be significant though, because I do have a decimal point. So I count all numbers except leading zeros that are in the front and trailing zeros without a decimal point. So all of these are going to be significant. So I have 4. So 402, do I have any leading zeros? No, I don't have any zeros in the front. Do I have any zeros in the back? No, I don't have any trailing zeros either. I do have a 0 in the middle, but that's not a leading 0 or a trailing 0. So they're all significant. There's 3. So I have 3 significant figures for rounding purposes. So now the next one, I have 5,280. Well, do I have any leading zeros? No. Do I have any trailing zeros? Yes. But is there a decimal point? No. So I do not count this. So I have 3 significant figures. Now I'm not saying that the 0 isn't important, because if I take off at 0, that becomes a very different number. I'm just saying for rounding purposes, it's not significant. Now, the next number, do I have leading zeros? Yes. So I have this one and this one. Okay, so even though it's behind the decimal point, it's still considered a leading 0. So those do not count. They're not significant. Do I have a trailing 0? Yes. But do I have a decimal point? Yes. So I have 2 significant figures. All right, so you could also be asked to round numbers to, oh, I'm sorry, not decimal places, 3 significant figures. We're going to round these to 3 significant figures. Okay, so what you do when you're trying to round is you look at your number, you go to your 3rd significant figure, okay, and then I look behind the 3rd significant figure, and that tells me if I need to round up or down. If the number behind the 3rd one is a 5 or above, it rounds up. If it's below 5, it stays the same. So let's look. Okay, we're going to count. This is the 1st significant number, 2nd, 3rd. Okay, so what's behind the 3rd significant figure? It's a 5. So if it's 5 or above, it rounds it up. So it becomes 3, 4, 1. Well, thing is, I can't leave it as 341 because that's a very different number. That is some funky rounding. So now I can fill in with zeros as placeholders. So I would do 1, 2, 3 zeros to fill in the holes. So then this would be reported as 341,000. Okay, so let's look at the next one. Okay, so let's look at this. Okay, I want to round this to 3 significant figures, but there's a problem here. I actually only have 2. If I look at this, I have 3, 4, so those are significant, okay, but I don't count trailing zeros when there's no decimal point. So I'd still go to the 3rd number. But if you get to a situation like this, what's going to end up happening is you need to actually put it into scientific notation. So we're going to put this into scientific notation, and then we're going to put it into 3 significant figures. So 1, 2, 3, 4. So it would be 3.4 times 10 to the 4th. I moved it 4 times. Now, this is still only 2 significant figures. When you look at scientific notation, all of these numbers are considered to be significant. So if I wanted this to be 3 significant figures, I could simply add a 0, because now that 0 is the trailing 0, but there's a decimal point. So this would be 3 significant figures. So if you get to a situation where you need to round to 3 significant figures, but you only have 2, or you need to round to 3 and you only have 4, or you don't have enough, you're going to put it into scientific notation. Okay, so now let's look at this. So leading zeros are not significant for rounding, so we're going to count 1, 2, 3. This is the 3rd significant number. There's a 5 behind it, so the 5 would round up. So it's going to be 0.00406. Now, you can't leave it as 406 because, again, that's a very different number. Make sure you leave the leading zeros there. They are not significant. If you have it as 406, that is funky rounding. That is a very, very different number than 0.004. All right, so really and truly what ends up happening with your measurements is you usually do a calculation. So the reason we go over this is so that we can talk about what you actually do to round appropriately, not just the math teacher's method of rounding to 2 decimal places. Okay, there's a very specific set of rules for rounding. So if you are multiplying or dividing, the number with the fewest significant figures determines how many significant figures are in your answer. Okay, so let's look at this. Okay, this is a calculation you would do. This is the answer the calculator would spit out. Okay, how many significant figures are here? I have 1, 2, 3, 4. Okay, no leading zeros, no trailing zeros. Okay, so that's 4. And then the next number, we've got 1, 2, 3, no leading zeros, no trailing zeros. Okay, well, my least precise measurement is 3 significant figures. So my answer needs to be rounded to 3 significant figures. So I go to my third significant figure, which is the 4. There's a 1 behind it. So since it's below 5, I'm going to keep the 4. And then my answer should be reported as 324, because that shows how precise my measurements are. Okay, if you add or subtract, it's a different rule. Okay, the number with the lowest place value determines the place of the last significant figure in the answer. Usually, this just easily translates into the lowest number of decimal places determines how many decimal places your answer will have. Okay, so for this one, I have 2, okay, I have 2 decimal points. I have 1 decimal point here, so my answer will be rounded to 1 decimal point. So I go to my first decimal point, okay, it's 8. There's a 5 after it, so I'm going to round that 8 up to a 9. And it goes to 7.9. Now, technically, when I'm looking at this, I have the tenths place and then I have the hundredths place. This one does not have a hundredths place value, so I rounded to the tenths place. Really, because we've got 2 numbers with decimal points, the easiest thing to just say is go to the lowest number of decimal points. But you do have instances like this where they're whole numbers. So what we do is we say, okay, we have got a ones place, but this one has only got into the tens place. So I'm going to make sure that I put my answer, and the last significant figure in the answer should be the tens place here. So I've got a 4 after that, so I'm going to leave it as a 5. And then it rounds to 350. Now, typically in chemistry, we don't really work with whole numbers, but every now and then you might see an example like this. So you go to the not the ones place here, but you're going to go to the tens place. Again, usually you're going to see numbers with decimal points in chemistry, though. Okay, so when you calculate with significant figures, measurements are the only thing that can be used for rounding. So in your calculation, if you use an exact number, you don't worry about that. So like if I say I have 12 students and I'm somehow using that in my calculation, I don't care about that. That's not a measurement. If you have a conversion factor, so a conversion factor would be like 1 meter is equal to 100 centimeters. This has no bearing when I round because it's an exact number. It's not a measurement. Okay, so let's do a few practice problems. Okay, so when I plug this in the calculator, I'm going to get this. So this is division. So if I'm dividing, I go to my rules. My rule says I'm going to go to the lowest number of significant figures. So I have 4 significant figures here. I have a trailing 0, but I have a decimal point. Okay, and then I have 2 here. Okay, so I want my answer to have the lowest number of sig figs, so 2. So I go to my second significant figure, which is a 3. I have a 9 behind it, so I'm going to round it to 2.4. And don't have any zeros behind that, because if I put a 0 there, that's more significant figures, because there's a decimal point. Okay, so the next one. Okay, well, I have a subtraction problem. The rule for subtraction is that we go to the lowest number of decimal places. So I have 1 decimal place here, I have 2 here. Okay, this is what my calculator spits back out. So I want my answer to have 1 decimal place. So my first decimal place is 0. There's a 6 behind it, so it rounds up to 18.1.